Hello, everyone. I want to finish out talking about Section 5.3 by applying Hess's law. And much of what we have talked about in the previous two videos has been building to the point of being able to have this discussion. So those are sort of foundational bits of information that we'll need to do what comes next. So I want to do a really quick recap of some of the important points. If they seem a little odd to you or you don't know what they mean, go back and watch the previous videos to understand those concepts before watching the rest of this. So there's basically two things we are going to need to do this. One of them is the information about the standard enthalpy of formation. We will be using this extensively in this section or in this video, and the things that you'll be doing based on this video. And this is the idea that you can look up values for any compound and use those values in doing thermochemical calculations. So Appendix G, you'll be going there to get the numbers that you'll be using for these calculations. So that's one idea. The other idea is Hess's law. And this is basically that you can combine any process and do it in any order. So it's a state function. Doesn't matter how you get there. You can get there the way that makes the most sense. And so it turns out the way that makes the most sense most of the time is what we're showing in this equation right here. And this probably looks a little unclear to some of you. And I want to spend a little bit of time going through what's going on here and what this means. What we're doing is we're basically taking the reaction and we're taking all of the reactants and we're breaking them apart into their elements. And then we're taking those elements and putting them back together into the products. And so this is showing what that means. So the enthalpy change of the reaction at standard state, so for the whole reaction, we add up the enthalpy changes of all the products. And that's what this means here. So the Greek uppercase sigma here just means that you're adding together a bunch of things. And you don't necessarily specify how many there are because it could vary from situation to situation. In some cases, you might only have one product. In some cases, you might have 3 or 4. So it could be whatever it needs to be for that situation. So what that means is you look up the enthalpy change of formation, the heat of formation for each of the products. The N here is meaning the stoichiometric coefficient of the product. So for each product, you multiply it by, you look up its heat of formation, multiply that by its stoichiometric coefficient. And then you do that for each product, and then you add them all together. You do the same thing for the reactant. So you look up the heat of formation for each reactant, multiply them by their stoichiometric coefficients, add them all together. So you do that for products, then you do that for reactants, and then you take products, the sum of the products minus the sum of the reactants. That is the heat of formation, or the heat of the reaction, the enthalpy change of that reaction. So again, what this is showing is it's saying for that reaction, what we're doing is we're taking all of the reactants, blowing them up into their elements, taking those elements, recombining them as their products. And this math is showing that process. Now, is that how the reaction actually occurs? Maybe, but we don't care. It doesn't actually matter at this point how that happens. Because this is a state function, we can take any path from reactant to product and it will still work. That question of is that actually how it happens is a question for a different area of chemistry that we won't get into until next semester. So what you're doing here is you're taking a shortcut, but we know that the shortcut is okay. And in thermodynamics, we can often take these shortcuts. So we want to set it up so that we can take shortcuts. So let's look at an example of using Hess's law. So we're given a reaction, so NO3NO2 plus H2O to give us 2HNO3 plus NO gas. So we're going to be using this equation to solve that. So what we'll do is we'll look up heat of formation for each of the products. So we have two products here. So we would go to Appendix G, and there's a link here again to Appendix G, and look up those values. And then you have coefficients of 2 and 1. You would go to Appendix G to look up the values for the reactants as well. Coefficients here of 3 and 1 on the reactants. So I think the best thing is to pause your recording, go do that, look up those values on Appendix G, and see if we're getting the same thing as we go through this. Okay, so I'm assuming you've done that. I'm assuming you've gone and looked those up. And now we'll look at what the answer key is telling us. So for the products, we have 2HNO3. This is the number you should have looked up. And then 1NO, and this is the number you should have looked up for that. So hopefully that was pretty clear. For the NO2, we have 3. This is the number you should have looked up. And then 1H2O, and this is the number you should have looked up for that one. I want to just pause just a minute. This is the one where it's most likely that you might have picked the wrong number because there are more than one H2Os in that table. So just double check that you looked up the right number for the heat of formation of H2O. So at that point, it's just a matter of doing all of that arithmetic to get to the final answer. So this is the process. This is kind of what we do with Hess's law, and is sort of the culmination of this chapter, is being able to look these values up in a table and then put them into this form to find the heat of reaction for the entire thing. So this is a little bit of a tedious process, but you want to be comfortable doing it. Definitely something that will be highlighted from this chapter in any sort of quiz or exam. There is kind of a little bit more of a discussion of that here, if you would like to see that, and then another example that you can check your work on. So good luck, everyone. That is the end of Module 5.